3 to floor 2, any like combination. It's not like strict to just one direction. We also needed to have buttons to know which floor you want to go to, and like lights to indicate if you arrived on the floor. So like this is our like final project right here. So before we demonstrate how it works, we should go to like the design.
Yeah, so the sketches, we started actually like all of this. I mean, like looking back, I can't really tell what any of this was, but we looked up photos of like how like actual elevators open, and like, because I was thinking like, I mean, surely like the way they actually do it is probably the best. And they use like this like kind of this chain thing, kind of similar to like you can see it right here. But like they have a chain that will like spin one way, and then like the doors will be attached to like different parts of the chain, so like when it spins it'll like open. We didn't end up doing that though.
Yeah, the problem was we didn't have enough time and resources. Yeah, the gears, it looked weird because in our old design, the gears were going to be on the outside, and that doesn't really look presentable for people to look at. And basically the pulley at the top caused some problems because you need to have like some sort of like distance between like extra pulleys on top so they can like stabilize it and it doesn't like break the strings. So the final, like our final sketch is just like part 1 of the final sketch. Like the doors we decided to pick just a single door because it saves more time and resources. And basically you click the button to open and close the doors, and like there's a button and the lights is down there. It ended up in our original final product over here also. And our full design basically is just a layout of all the like doors and floors like all stacked up together. And basically this is how the pulley mechanism would work. We have the pulley on top, and the motor like spins and like lifts up the elevator. And the sensor down here indicates which floor it's on. So it was like, so we can know the distance of how far, like which floor we want to go and if we've arrived or not. Like the old code, yeah, you can just basically say.
Okay, yeah, this was, it says, I'll just like read it. It says when button is pressed, open door to allow like enter to like put stuff in, and then after like a few seconds it'll close, and then the elevator will lift to like whatever button you pressed, and then once it's at the floor with like the values of the distance sensor, then that's when it will stop and open the door.
Yeah.
And then down here says after a certain amount of time it'll lower the elevator to the first floor, just to like, because that's what like actual elevators do.
Yeah, the problem is too simple, and it included like other stuff like the motors and like how the timing and all that stuff. So the new code, basically we had like 3 steps. So this is like the original, like the first function, basically the run function. What it basically does is like you press the button, opens the door, waits a certain time, closes it, and then it moves to the destination floor you want to. And then it opens the door for a certain amount of time and then closes it. And you basically, that's how it works. That's like the raw, like deep, like overview of the whole program. And to go deeper, we have like the move function. We indicate like we have like motors spinning and like reverse if it wants to go up, motors spinning forward if it wants to go down. And we have the button like to open the door, which basically spins the motor inside. If you see here, the motor inside here will turn this gear so the door would open and spin it the other way so it can close. And just more pseudocode, basically the button pressed, it checks like, we have multiple buttons, so we need to know which button is pressed. So we just loop over all the buttons that are available, and we basically check if this one is clicked, it basically, that's the floor we should go on. And the flashlights basically just, since we have the button which indicates the floor we're on, we just use that floor number to indicate which light should be turned on and off. And basically this is our final product. But
there's like 2 other videos there.
Yeah, but the videos aren't working, but we have the code right here. And so I'm gonna demonstrate. I hope.
And when you demonstrate, can you demonstrate it from this perspective as well as the back?
Okay. So this is like the front view. So I'm gonna go to floor 3. Okay, download it. So what it will do, it will open floor 1, so you can put the weight inside. After I put the weight inside, it would take like 8 seconds to close. And it's closing. And now it's lifting the elevator up using the gears and the pulleys. We just like put on the top. And after it reached the floor, it's pretty slow, but we wanted it to be slow, like a real elevator. and then it blinks the lights so you can indicate you're on that floor, opens the floor. I take my stuff out, and basically you close it, and it closes the door, and you basically arrive at your destination you want. And to demonstrate, it can go to any combinations. I'm going to go to floor 2 now. So it opens floor 3. I put my weight inside here. It can lift up to like 3 kilos, I feel like. And it closes the door after a certain amount of time. Goes down to floor 2.
Wow.
Opens floor 2. And yeah, you take it out and you should close it. And closes it. And basically, it has like a mechanism, but we don't really want to wait that long. It will automatically go down to the first floor, which is part of the code, after a certain amount of time. But the code is like 25 seconds, and I don't know if everyone wants to wait 25 seconds. But while we took the distance sensor down here is basically going to indicate which floor it's on. We use this like mat so it can be more secure, because the original design actually, like the typo, see it's going down after 25 seconds of inactivity. So basically the original like metal stuff, they have holes, and it didn't seem reliable to use like stuff that has holes in them. So we use like an actual like blank, like,
I measured like the
you explain it.
like that thing, and we had like cardboard, and I just like cut it out the square so it has like a floor.
So it can be more reliable to this, and there'll be no errors. So basically we're just gonna do everything we did again, but just from the back view.
So to go to the 3rd floor.
Opens the first floor, and these give. You see that the motor is like spinning it over down here, and in 8 seconds. So we have this pulley mechanism up here that's basically run by motors over here. The gears over here are used so they can spin in equal speed, so it doesn't like one automatically goes faster and the other one goes slower.
Smart.
And these like 4 things here are just like
To stabilize
guardrails,
it.
so it's
So-
not like swinging around.
So it doesn't swing around. We wanted to make it stable also. And
Yeah.
this opens the door with this gear motor over here, and basically closes the door after 8 seconds. And yeah, that's basically our whole project done. Like it does that. Any combination you want, it can just go there.
I have one question before you conclude. Can you explain the physics behind, in terms of forces behind the elevator system?
So when you have like, when you're standing on it, you have the normal force, and the normal force is like pointing up, like basically the direction of where you're standing, the opposite direction, so you don't like fly into the ground. So the normal force, you're standing over here, the normal force is up. When you're going downwards, the normal force will be, less than your actual gravity force. That's why it's able to go down. But when you're going up, the normal force is greater than the actual like elevator gravity. So that's why it's able to go up. Yeah, so force is measured at mass times acceleration. The acceleration here is basically 0 because it's constant, but it needs to accelerate a little bit to go up to that speed. So that's where the normal forces change and all that. Yeah, that's about it. And we have the conclusion questions over here. Basically, what difficulties we had. We basically had like, the problem we had was we were running out of supplies. So we had to like go to Miss McLeod's class to ask for some supplies. And so basically we had to thank her for all the resources we had also. And the successes we had is that we were able to finish it, honestly. I didn't know we were actually able to finish this design, but I'm actually grateful. We had to come after school to finish it sometimes. And basically what we can learn is that if you have something in mind, you'll be able to accomplish it if you have like support and also like put your mind into it. And basically things that we wish we could have, we wanted to have like a power off switch. So suppose there's an error, we can automatically like power it off and like automatically goes down and then powers off. And we wanted to have double doors, but that seemed a little too complicated and the space wasn't as big to like accommodate to all that like double door system. And it looked, our design for it like in the first stage was a little complicated, so we just stick with a single door. Yeah, that's about it. Thank you for listening.
That's great, awesome.